Okay, per request of one of my listeners, I am solving the following problem that involved calculus, rate of change. So what do we have? A water tank at a filtration plant is built in the shape of an inverted cone with height 5.2. Okay, we have here the height, which is uppercase H, equal 5.2 meters. And diameter is 5 meters. So we have here R, so I put 2R, which is diameter, right? Right down here, diameter is equal 5 meters. From here, I'm going to put R is equal 2.5 meters because radius is a half of diameter. Okay, at the top, we have it. It's right here. Your uppercase R. Water is being pumped into the tank at a rate of 1.2 meter cubed per minute. So at a rate, which means we are talking about derivative, dv by dt. So it's going to be, it doesn't say the volume, it says rate of change. It's a rate of 1.2 cubic meters per minute. So dv by dt is equal 1.2 cubic meters per minute. Okay, find the meaning rate of change, at which the water level is rising, where is 8 pi meter cubed of water. So volume, it's talking about this green part, where we need to find how fast, practically, how fast the water level will rise to the level of V with the height of H. It's going to be 8 pi m cubic meters. So when we say how fast, when you fill it up, the level of water is rising, right? Meaning the height is rising and accordingly volume is increasing. So we need to find dH lowercase, dH by dt when H is equal, we don't know. We need to find out this H. I will put this way, dH by dt for V of H, 8 pi meter cubed. And this is our question mark. Okay, so first thing first, we know that the volume of the cone is equal, let me write down red color, at least this color, V is equal 1/3 pi r squared h. So as you can see, I used here all uppercase letters. This is for entire cone we have, right? Now, the volume for the level we are interested in, and we are interested in 8 pi meter cubed. So I can write down even here 8 pi, this green one. That's what we need to know. So this 8 pi meter cube, which is I'll put volume for H, it's going to be equal 1/3 pi, but here I'm using lowercase radius, right? And lowercase h. Okay, so to find the rate of change, we need to get derivative, which is going to be d vh by dt is equal 1/3 pi lowercase r squared, and dh, since I'm doing by dt, and we're gonna get dh by dt. This is our main formula. This is what we are going to follow. Once we have everything we need, smaller radius, the height, right? We can find out our dH by dt. This is what we need to find out, dH by dt, right here. And we will have our rate change for the level where volume will be 8 pi meter cubed. So the problem is we don't know lowercase r, we don't know lowercase h. How I'm going to find out? This is what I'm going to do. I'm going to do, maybe let me make it a little bit smaller so we can reach out from the end of the, tiny bit. Okay, I'm going to create proportion. What kind of proportion I'm going to create? So I'm going to write down OA is related to BC. Look here, OA related to BC, yes, exactly the same way as OD related to BD. So if I provide these dashes, that's the height, right? OD to BD, yes? Because uppercase R radius is associated with uppercase H, the height of entire cone. Lowercase r is associated with lowercase h for green part of the cone, right? The one that filled up with the level we are interested in. All right, so from here, what do we have? My OA is equal 2.5. My BC is just R. My OD is 5.2 because uppercase H is equal 5.2, right? And my lowercase h, we don't know. So from here, I'm going to get 2.5h is equal 5.2 r. Yes? And r from here is equal, we are going to divide 5.2 here, right, to get r, and 5.2 here. So our r is going to be equal 2.5h over 5.2. And this is gone with this. So we got our lowercase r expressed through h. Okay, so we need to know our h. How I'm going to do that? Based on formula, v is equal 1/3 pi r squared h. I am given at least this volume, 8 pi. Yes? I am given that volume at 8 pi. So what am I going to do from here? I'm going to, let me write down the formula I'm going to follow. VH, right? 1/3 pi lowercase r squared h. Okay, so I'm going to substitute this r with the value of r we figured out. So VH is equal 1/3 times pi times r squared. It's going to be 2.5h divided by 5.2. This is squared and time h, right? This is what I'm using. All right, next. Now I'm going through simplification, through a little bit algebra. My VH is going to be equal 1/3 pi, and I'm getting 6.25 over 27.04. Don't let me add here 1/3. Okay, and times h cubed, right? Okay, so we know that our volume on the level of h is 8 pi, correct? 8 pi. So I'm writing down 8 pi is equal 1/3 of pi times 6.25 divided by 27.04 h cubed. From here, h cubed is equal 8 pi dividing by this entire piece here. When we divide, we flip it, right? So it's going to be 3 times 27.04 and dividing by pi times 6.25. This pi is gone with its pi, right? And we are getting h cubed is equal 648.96. Let me double check. 27.04 times 8 times 3, 24. Yeah, correct. And divided by 6.25, and we are getting approximately 103.8. So from here, h is equal cubic radical of 103.8, which approximately will give me 4.7. Let me double check one more time real quick. 108.8 cubic 4. Well, I could put it's 4.7734, almost 4.8, I would say. We could round it up till 5 if you want, so for the sake of easiness. I don't know it based on requirement, but 4.8, okay. 4.8, we work with this 4.8. All right, we solved here is the major key issue here. We found the hive we didn't know. That's what was holding us from calculating the rate of change. So once we have it, I can plug here. See, I have h. Now I can plug here dv by dt. Let's go plug here. So dv of level h by dt is equal 1/3 pi. I am not afraid of lowercase r because I don't have it. For very simple reason, we have already, here it is, we have already expressed it through h, right? So I will end up having everything. Pi r squared, and here we have dh by dt. Okay, let's plug the value of given data. So what do we have? dv by dt, rate of change of volume, it's 1.2, right? Here we have dv by dt 1.2. So we write down here 1.2 is equal 1/3. Well, I might as well pi here. So our r is what? 2.58, right? Times 2.5 h divided by 5.2, right? All this squared and times dh by dt. Okay, so since I have here h squared, it's going to be, let me see, I'm going to squeeze in under this derivative because it's also h 1.2. This is what I'm going to do over 3. 2.5 squared is going to be 6.25, right? And 5.2 squared is 2704. And this h squared I have, it's going to get here, dh cubed with this h by dt, right? Okay, so from here, what we are going to have, we are going to write down, take derivative, dh cubed by dt. It's going to be 1.2 pi. Let me see if I can divide by 3. 6.25. 6 plus 2 is 8. 8 plus 5 is 13. No, I can't divide. All right. Times 6.25 divided by 3 times 27.04. So dh cubed by dt, it's going to be, it's going to be times 3 h squared and dh by dt, correct? dh by dt. And from here, we will have dh by dt is equal 1 over 2 divided by, let me move this on the top, and we need to divide by the whole this fraction, which means I'm going to flip the fraction, right? This 3 times 27.04 comes to the top, and pi times 6.25 times 3 h squared. How much is my h? We calculated 4.8, right? 4.8, since it's square, I'll put twice, 4.8. Not a big deal. So at the 3, I can reduce with one, cancel even, not reduce, with this 3. So 4.8, I can divide by 1.2, right? This 1.2 is gone. This is going to be 4 times. And what do we have here? Let's see. dh by dt, it's going to be equal 27.04. I'm going to multiply all this. What do I have? 6.25 times 4 times 4.8, and we are getting 120 pi. So 27.04 divided by 120, we are getting approximately 0.20, hold on. Yeah, 0.23 over pi. Yeah? So this is going to be what? Meter per minute, change meter per minute. Or if I want to also get the real number of change without this pi, so I'm dividing also by 3.14 and getting dh by dt, it's getting approximately 0. Okay, let me write down so you would know what change I did. 0.23 divided by 3.14. So approximately this is going to be equal 0.072, something like that, 0.072 meter per minute. This is our change. And this is our answer. Now, since there is a lot of the basic calculations, I might did somewhere some silly mistakes. So just watch it out, check it again. And if you find it, just let me know also. I would gladly fix it. All right, thank you for watching. This is a very popular problem for rate of change. So I hope you understood. If you have questions, please post it in the comment. Subscribe to my channel if you like it, and we keep working together. Bye-bye.